Following up on the artifacts piece, which we mentioned as part of the signs that of mammals left behind, skulls are one of those things which can be found in the wild, and of course you can identify right down to a species as long as you have several of the key components of the skull still intact. And being bone and very unlikely to be degraded naturally, and if it's not crushed or damaged, you should be able to find or be able to identify the species in question that you found. Skull identification begins with understanding all of the different components that make up a skull. So when you look at a typical skull, you'll see really there are two parts. There's the mandible, which is essentially the lower jaw, which fits up into, connected with tendons, etc., that would be present in a live animal, to the upper part of the actual skull, which contains different bones. The parietal bone towards the caudal end, the orbital, the maxilla, okay, different teeth, like for example incisors at the front, large canines, premolars, molars, all of these different components that make up a skull. And for the purposes of this course, we would normally be measuring skull length as well. Now, that's not going to be practical in an online course where that's not possible to do. So instead, we'll be pulling out several of the unique anatomical changes that occur across species of the skull level. But skull length, the total length of the skull, is one of the key indicators for identification of species. There are other ways, as I mentioned. For example, looking at this, you'll see that from the top view, not only can you look at skull length, but you can look at several other things. In some species, you see that sagittal crest, which is along the caudal end of the skull. So that crest may or may not be pronounced in some species. The zygomatic arch, which may or may not be present in all species. The maxilla, the long snout-like projection of the skull, which is typical of the Canidae family, may not be present in all and is not present in all skulls. So understanding what you're looking for relative to the skull, we can get at the species level by looking at those unique features. In addition to length, we also look at width. So the width of the skull is almost as important as the length because, of course, certain species have different shaped skulls, not only different lengths but different shapes. So understanding the width of the skull is also just as critical. And now we're going to look at several different views and terminology that we use when describing a skull. So the mammals that we're going to talk about today are all four-legged, which means that they have four paws on the ground. Unlike us, which of course only have two, we are bipedal, which means we stand upright. They of course are not. So the back of their body is facing upwards. Okay? So when you're looking at the dorsal view, dorsal meaning towards the back, what you're looking at in the dorsal view of the skull, of course, is the top of the skull because that's the direction it would be facing on a four-legged animal. So this is the dorsal view of a coyote skull. This is now the lateral or the side view of the skull. So lateral means of the side. So from the side, this is what the skull would look like in a coyote. The ventral view, and ventral means of the belly, is if you were looking from the belly up, what would you see? Well, this is the ventral view of the skull. This is towards the underside. And here is where we can actually start counting the different teeth. So here on a particular side, I can see 3 incisors indicated in eyes, 1 canine. I can see 4 premolars and 2 molars. So again, we can start counting teeth when we're looking at the ventral view of the skull. The anterior view is towards the front. So if you were looking at an animal straight in the eyes, this is what you would see, of course, in a beaver. So here we're looking at, as you can see, very different than the structure of the coyote, a very different altogether. There's only 1 incisor on each side for a total of 2, and they're quite pronounced. So already we're seeing changes in dentition relative to these different species. And finally, these are the views from the back of the skull. The posterior means towards the tail, or caudal is another word for that as well. So from the back, from the posterior, what does the skull look like? So we can see the sagittal crest at the back. We can see the foramen magnum, which we'll come back to in a minute. We can see the zygomatic arches. We can see several of these characteristics of skull identification. Now there are some features of the skulls that we need to spend some time talking about. One, we've already talked about the mandible being the lower part of the jaw, but the diastema is in some ways a space that allows animals to move food from the side of the mouth and consume more food at once. So in our herbivore species, these are the species we will find that in. Our carnivore species will not have it for the most part because of the nature of their dental structure. So diastemas are something that we look for, and that allows us to narrow the gap in terms of what kind of species we're working with. We also look at the nasal cavities, so we look to see how the nasal cavity is created. Is it a long snout in a coyote? Is it short and squat? So those are the shape and the size of those are important. We also look for things like auditory tubes. And those auditory tubes, as you can see here on a beaver, these little sort of Shrek-like horns, they connect the middle ear to the throat. And so this tube allows air to pass between the tympanic cavity and the outside of the body by way of the throat and mouth. So again, that's a key feature for this individual species that we would look for when we're identifying that skull. So the rostrum, or the snout, and the sagittal crest are features that we've seen before. So as you can see in this case, the rostrum of the skull of a coyote is long and narrow, typical of that species type. The sagittal crest is pronounced. We see this nice pronounced arc of the sagittal crest at the back, which would lead us to identify this particular skull as a coyote. And also the foramen magnum is an important identification tool as well. So the foramen magnum is actually the hole that connects the spinal cord to the brain. So that is a large orifice at the back of the skull, or on the dorsal, or sorry, the caudal end, posterior end of the skull, which is where you see the connection between those two areas. And the size of it, the shape of it, is key in species identification. So the postorbital process is something else that we would pay special attention to. This, as you can see, it's a small jut out of bone, essentially, that is unique in some species and in some cases forms an entire socket all the way across to the zygomatic arch. So again, in some species we use this as an identifier to determine that unique character. And also the palate, which is the hard bony surface at the upper, just below the rostrum, essentially in the upper side of the skull. That size, shape, texture are all key features in skull identification. So in combination with some of the unique features of skulls that we've just talked about anatomically, we also actually look at the teeth and the teeth arrangement and the teeth number. So what might surprise you to know is that not all species have the same numbers of teeth and the same types of teeth. There are 4 types of teeth: incisors, canines, premolars, and molars. And in fact, comparing between species and even comparing between groups of animals like herbivores versus carnivores, there are pronounced differences. So not only are there things like diastema differences and postorbital process differences, but there's also teeth differences as well. So we can actually count teeth. So what you do is you look at one side of the upper part of the skull, one part of the lower side, which is the mandible, one side of each, and then you count them. How many incisors are on one side, how many canines, how many premolars, how many molars are on one side of the upper part of the skull, and how many are on one side of the lower part of the skull. And when you put that together, you will actually get that species-specific dentition formula. So for example, in a sheep, they have 0 incisors on the top. They have 0 canines on the top. They have 3 premolars on the top, and they have 3 molars on the top. On the bottom, they actually have 3 incisors. Notice the incisors are absent on the top. 0 canines, 3 premolars, and 3 molars. A dog, for example, has 3 incisors, 1 canine, 4 premolars, and 2 molars on the upper part. And on the bottom, they have 3 incisors, 1 canine, 4 premolars, and only 3 molars. So those are things in which we use to identify at a species level based on dentition and arrangement. Here's just an example of when you're doing your counting, some of the ways in which you could have different species. So showing you here across many different species. So Arctic fox, coyote, polar bear, gray fox, black grizzly bear, red fox, etc., raccoon, elk. There are all different kinds of dentition formulas. So varying numbers of incisors, canines, premolars, and molars add up to a total. So the total number is different, but also the arrangements within each category is different. And they also differ in many cases between the upper and lower parts of the skull. And also another thing is the orbits, the eye sockets themselves. The size and the positioning is also very important. So in a predatory species, for example a lynx, they have large orbit to skull ratios, so the eyes take comparatively a much larger proportion of the skull. The orbits are located towards the front of the skull, which means that they have binocular vision, which is overlapping vision points. That allows depth perception. That allows the ability to gauge your jumping, and so you can jump on your prey species. So binocular vision, of course, allows for very complex and dexterous movements. On the other hand, prey species, they tend to have a little smaller orbital to skull ratio, and the positioning of the orbits is different. The positioning of the orbits are actually towards the sides of the skull, not towards the front, because what a prey species is more interested in is detecting sudden movements from a much wider variety or scope of vision. So for example, peripheral prey species can have up to 270 degrees of vision, whereas in some species the binocular vision of, say, a human is significantly less than that, 90% or so. So again, it really does affect whether a prey or predator, and also the impacts on the identification as well. It's not something you can identify per species per se, but you can certainly make some assumptions based on its diet, basically its structure within the trophic level, based on its orbit and positioning. And now we're going to start going through individual species now and talking about or explaining a little bit about the identification features for both of these. So we're going to start with a red fox. One of the things to note is, being a carnivore, there is no diastema. Okay, so there's no space within the skull. It's all filled with teeth. There's one canine and 3 incisors on each side of the jaw. There are cheek teeth present in this animal. So what is a cheek tooth? A cheek tooth is any of the posterior chewing teeth on each of the sides of the upper and lower jaws. Now, what's interesting about the red fox is that the last upper cheek tooth is wider than it is long, and the 6 cheek teeth on each side of the upper jaw are, well, basically different in size. They are more long than they are wide. The posterior margin of the palate is even with the last upper cheek tooth. So these are some of those features that come into play when looking at a red fox skull. And let's contrast that to a gray wolf. So we're still in the same family, but of course we're dealing with a much larger species. So right off the top, the skull is significantly larger. So the skull length is larger. There's no diastema. There's one canine and 3 incisors on each side of the jaw. Last upper cheek tooth is wider. So the jaws are actually very similar in sort of their dentition, in terms of their anatomy being from the same family. That makes sense. Size is one of the biggest features that sets this one apart, in addition to a smooth postorbital process. So again, there are some unique features, but size in comparison between the two canids are really the key feature to look at. And now we'd like to look at a different species. So this is a black bear, different family, so we're going to have different structure and different dentition. The first thing we notice, of course, is that the rostrum is not elongated like it is on our canids. So long snout certainly on a fox and on a gray wolf relative to skull size. Of course, this is a much squatter skull. We see large canines, similar to that as well. Poorly developed carnassial shear. That's how the teeth, of course, connect with each other as they move up and down move across each other. The diastema is absent. It's filled with molars, of course. And what's interesting about the dentition of a black bear, of course, they're omnivorous. So they have all the teeth structure. So, for example, they'll have incisors, canines, premolars, molars as well, all in relative the same structure as what you'd expect from an omnivorous animal like a human. So other than the molars, which were extremely pointy in both the coyote or in the gray wolf and the red fox, the molars here are actually flat, because they're also, of course, engaged in eating, as you can see from the picture, vegetable material which requires grinding. The last upper cheek tooth is longer than it is wide, similar to what we've seen previously. So again, these are some of the features we use when looking at the black. And jumping family again, this is from the Felidae family, so this is the Canidae lynx, so still a carnivore, so those same features. We've got upper incisors, we've got a diastema, 1 canine, 3 incisors in each of the upper jaw. We've got all those carnivorous features, so binocular vision, but I want you to look at the shape and the structure of this particular skull. Notice that there's no rostrum, it's very squat, almost circular, round in shape, very compact, large canines relative to the size, but also more importantly, look at the size of the orbits, or the eye sockets in this case. They're huge because, of course, being, in some cases, in some ways, a nocturnal hunter, that would require extra vision capability. So there is a lot of optical requirements for this particular species. So those are some of the features which we would look for when looking at a Canidae lynx skull. So in this family, jumping into the Mastilidae, so we've got a northern river otter. Very different life history. So we are now no longer a carnivorous terrestrial animal. We're, of course, now aquatic. So we still have upper incisors. We still don't have a diastema, characteristic of carnivores. We have 1 canine, 3 incisors on each side of the jaw. Notice these are all repetitive across the last 4 species we've done. The last upper cheek tooth in this case is wider than it is long. We've got 5 cheek teeth in the upper jaw, which is different, say, from the fox. The rostrum, though, is wider than it is long. Look at the skull formation. It almost looks like it's squished and elongated. So this is a very different structure. This is, of course, because we're cruising along the surface of the water, so the upper part of the skull is very flat, and we're skimming across the top of the water. Notice we still have large canines here, right? We're a carnivore. We have no sagittal crest, which is different than what we've seen before. Large infraforaminal foramen, so the space around the side of the skull. But again, these are all features we would use. The shape, though, is very different than the four we've seen previously, and that's probably for this course enough to be able to recognize that. The raccoon skull, significantly smaller, of course, than the black bear, for example, still have that typical carnivorous upper incisors, diastema absent, one canine, three incisors. There's six cheek teeth here. Notice the shape of the skull, though, is quite different. So we've got a little bit of a rostrum. We don't have the elongated skull that we saw in the river otter, but we also don't have the very circular skull present in the lynx. So again, there are some structural differences here. For this course, that's sufficient to be able to recognize. And last, a completely different family. We're going to end up with the Virginia opossum. Now, this is interesting. We still have those typical incisors present, but what's interesting is the number of them. So we've got one canine and five incisors on each jaw, so we can see characterized at the anterior a lot of very small but numerous teeth. But the structure of the skull is radically different. So we still have large incisors. Notice the orbit, the structure of the orbit is quite different. The huge sagittal crest here at the back, though, is the number one defining feature that we'd like you to pay attention to. Notice that the skull is relatively elongated, more so than the raccoon, but it still retains that sort of basic structure. But the sagittal crest and the number of incisors on each side are the key features in identifying this particular skull. Now switching over to a different family, the Cervidae, we've got our white-tailed deer. This is a very different life history because, of course, these are not carnivorous anymore. So these are herbivorous, so there are no upper incisors. There is a diastema, okay, and there is a long nasal bone that extends beyond the cheekbone. So you can see here present in this long sort of snout-like creature, but you can see the diastema present there clearly. There are no canines present in the upper surface as well. Next in the same family is the moose. So we have no upper incisors. There is a diastema present. Relatively short nasal bone. You can see it projecting right there. It does not extend to most of the anterior cheek teeth. So you can see it actually cuts off prior to where the cheek teeth actually end, or towards the anterior side of the skull. So again, what difference is this relative to the white-tailed deer are those features, but also size. The size of the skull, as you can imagine, being a much larger animal, is significantly larger. So that's one of the key features we would use as well in identifying this skull. And now into the Rodentia order, we see in this case a beaver. So we do have upper incisors present. There is still a diastema given its herbivorous nature. There's one incisor on each side of upper jaw, and notice the size of them. So they're of course modified for gnawing wood. There is no post-orbital process present. What's interesting about the beaver, though, is that they do have an auditory tube, which is not very easily present in this image, but we saw it when we talked about auditory tubes previously. That's a unique feature of this particular species. The next on the still the same order, Rodentia, is the porcupine. So the porcupine has upper incisors, of course, for chewing wood. A diastema is present, one incisor on each side of the upper jaw. It's sharply pointed in terms of a post-orbital process, so you can see that present on the image. The auditory tube is not present, so very similar incisor structure to a beaver, but there are no auditory tubes. So that's one of the key things we would use to identify a porcupine.